What happens to the wavelength of a wave on a string when the frequency is doubled, and what happens when the speed to the speed of the wave? Because in both cases the waves propagate through the same medium, v is constant. V equal lambda times f. Lambda and the frequency are inversely proportional when v is constant. Then as f increases, the wavelength decreases. Why do sound waves need a medium through which to travel? Sound waves are mechanical waves that require a medium to propagate through. As a mechanical wave propagates through the matter, it causes the particles of the medium to vibrate, thus carries the energy of the wave from one position to another. So it is necessary that the sound wave propagate through a medium because its propagation is all based on the vibration of one particle causing the vibration of the nearby particle and thus transferring the wave carrying energy from one position to another. Two tuning forks with frequencies of 256 Hz and 512 Hz are stuck. Which of the sounds will move faster through the air? Although the two sound waves have different frequencies, as they propagate through the same medium, which is air, they keep the same speed. Both waves are of the same nature, both are mechanical waves, both are sound waves, and are produced by the same source. What is one advantage of transferring energy by electromagnetic waves? Light, for example, received by a plant from the sun is actually a group of electromagnetic waves. The energy carried by these waves is used by the plants to undergo photosynthesis and produce their food from raw material. The greatest advantage of EM waves is that they can propagate through vacuum to reach the Earth from the sun. So if this was not true, we won't receive any electromagnetic waves that we use for different applications or in different applications. So the greatest advantage is that electromagnetic waves, unlike sound waves or mechanical waves, can propagate through vacuum from the outer space to the Earth. A wave traveling in the positive x direction with a frequency of 25 Hz is shown in the figure up below. Find the following values for this wave: amplitude, wavelength, period, and speed. You are given here double the amplitude, so 2a is equal to 18 cm. Amplitude is measured from the equilibrium position to the crest, or from the equilibrium position to the trough. So 2a is 18 cm. A is half 18. It's 9 cm. Now the wavelength. The wavelength by definition is the distance covered by the wave during one cycle. It is the distance between two consecutive crests or two consecutive troughs. However, here we are given the distance between a crest and a trough, consecutive trough, so this is half a wavelength. So 10 centimeter represents lambda over 2, then you do cross multiplication. Lambda is equal to 2 times 10 centimeter equal 20 centimeter. Now given the frequency, we can calculate the period by applying the rule t equal 1 over half 1 over 25 Hz equals 0.04 seconds. D, the speed. V equal lambda times f is equal to 20 centimeter times 25 Hz. Hertz is the SI unit of frequency, so we have to convert lambda to the SI unit. From centimeter to meter, we divide by 100. Backwards by 2 digits, it's 0.2 meter. And the answer is 5 meters per second.